Hello, good evening to all of you. Can you hear me?
Yes, sir.
Thank you.
Yes.
Thank you. Okay, so we are going to start module number 2. So module number 2 is about hypothesis testing, and we are going to learn the process. And basically, this is 2 sample hypothesis testing. If you have more than 2 samples, we are going to use different tool, which is in next chapter. So let me start with 2 sample hypothesis testing. Please remember, before we start this, you can see this PDF at the end of the module 2. It has all screenshots like to so here you can see all the screenshots of Minitab and what we are going to use in this. So this is the complete Minitab screenshots, and how to start and how to check the 2 sample hypothesis testing is complete here. Now we are going to start the process. Process is very simple. Those who attended the previous class 503, for them it's very simple. A hypothesis testing starts with some hypothesis. Hypothesis means some assumption, some statement that we would like to check using a statistical method. Let's say a very simple hypothesis that I'm assuming as of now, that real estate or house prices are more in Seattle as compared to Spokane. And we all know, yeah, Seattle is expensive place. But yeah, this is just simple statement I made, as compared to Spokane. This is very simple statement. You can make so many statements and then you can statistically test. So hypothesis is, or then any statement. I would like to check this statement. And this is what is, I think, a discussion of this week. How I can do. So there are steps in order to do hypothesis testing. So this is my statement. I'm going to check statistically. Can you see my whiteboard?
Yes, sir.
Okay, perfect. Now, so the steps number 1 is to write null and alternative hypothesis. Null hypothesis is written like this: H0 colon, and we have to write like, housing prices or mean housing prices mu Seattle minus mu Spokane equal to 0. And null means, in theoretical, null means 0, no, nothing. So the difference between Spokane housing prices and Seattle housing prices is almost same. If both are same, then there is no difference. Therefore, it is called null hypothesis. Alternative hypothesis says it is written HA, or some people also write H1. Either way, both are correct. Some books. And mu S minus mu Spokane not equal to 0. This is means it is plus or minus, some value will be there, and this is alternative hypothesis. So first step is this. Number 2 step is, okay, at what level of confidence you are going to check? 95%. What is your significance level? So significance level 5% or 0.05. I'm going to check this 0.05. Third thing, collect data. I mean, I go and I can collect the data from collect data. Number 4, do calculation. And number 5, accept or reject null hypothesis. Accept or reject. And number 6, make your conclusion and decision. Make your decision and you can draw the inference based on this. So this is a very simple process. Some books have 4 steps, some has 5, some are 6, but basically this is the process that we are going to follow in hypothesis testing. So first thing, I made a statement, or sitting on a coffee table, we are discussing to our friends. Somebody is saying Spokane housing prices are more. My friend is saying Liberty Lake housing prices, and we are not reaching on conclusion. Eventually we decided, okay, let's do it statistically. So we made null hypothesis, we made alternative hypothesis, we decided, okay, this is our decision rule, 5% level of significance. Now the next step is to collect data. Like I said in discussion, you can go on Zillow, you can go on different website, realtor.coms or other, to collect the data. So that is what. So collect the data, you can do anyway. Now I'm going to do my own way. So just a minute, share new screen. Okay, now my mini tab is right here. So I'm just going to make a data. I'm not going to collect, but you can collect using, let's say, Redfin. And they have option to download data somewhere here. Recently, you can select the location, and then you have option to do it. So you can download. Zillow also has the data. So doing and collecting one by one, it's challenging. You can download completely. So here I go under Spokane, and let's say here under recently sold or sold houses, and I can just remove this and I can see sold houses, their prices when they are sold. Recently sold houses, you can see. So you can get data. Nowadays, data is available everywhere. So the next third step is to collect the housing prices or collect the data of houses. So I go on Spokane, and here I collect Seattle. Now, instead of doing, I'm just going to do random data, and I'm going to do integer. Where is integer? So I'm going to do in Seattle, and I'm going to do 50 house prices of Seattle. Okay. Oh, Poison, I'm just sorry. Data, where's a random data and integer. So I'm going to use 50 house store in column Seattle. What should be the minimum price in Seattle? I say like 500,000. 500,000 to, let's say, 900,000. Okay. And I got the housing prices, 50 house price in Seattle. Now I go and do for Spokane. So first thing first, again, random data, and I do integer. And now I go and select Spokane, and the minimum price is about like 425,000, and maximum is about 650,000. Okay. So I collected, let's say I collected the data for Seattle and Spokane. So the third step is done. Now fourth step is to calculate the statistics. So we have all options under this is basic statistics. Can you see this? Statistics, basic statistics, and under here we have one sample. We studied two sample T. Paired T test, we have two sample, paired T, two proportions, and two variants. So these are the four options we are going to use in this module. Again, I clearly explain here too. You can see under this PDF, you can see what options we are going to use: two sample, paired sample, two proportion, two variants. Can we do two sample Z test? No, we don't have, because we are having the sample only. We collected the sample of Seattle and we collected the sample of Spokane, and we are going to compare. We don't have any population related information. Is it making sense? We are going to, so that chapter is also two sample. You can see two sample hypothesis testing. In one sample, we were using against a standard value. We are comparing with benchmark value, which is related to population. Here we are just playing with the samples only. Is it making sense, Wang?
Yes, sir.
Okay, that's great. And so these are the four options we are going to. Now we are going to do calculation, statistics, basic, two sample. And now you have the summarized data. You can do the summarized data, means sample one, sample size, sample mean, sample standard deviation, sample two size, sample two mean, sample two standard deviation. If you have summarized data like in MCQ or fill in the blanks, you have summarized information that you can use. But here we have two sample. One is Seattle, one is Spokane. Okay. Now we have different options. Assume equal variance or not assume equal variance. This is another option. When do we assume equal variance? When do we assume unequal variance? So I'm coming over there in a minute. Hypothesized difference means difference between Seattle and Spokane is 0. Okay, this is a hypothesized. Alternative hypotheses are this: not equal to 0, less than 0, or greater than 0. We are going to work one by one. So here, assume equal variance. So before going into this option, I have to select one more thing, which is statistics. Statistics ANOVA test for equal variance. So here, responses data in separate column. So I have Seattle, Spokane. Under options, normal distribution. When do we use the normal distribution? When do we don't use the normal distribution? Normal distribution can be, do you know what is the condition from last class of normal distribution?
Isn't it a certain amount of numbers in a sample?
Yeah, more than 30 plus, 31 plus, and then we can say, okay, it's a normal. So all deviation, all distribution follow normal distribution if n is higher. Here we are using 50, which is higher than 30, 31. Look into this. Null hypothesis says, I'm going to make it bigger so you can. Null hypothesis is all variants are equal. Means variance of all sample are equal. We have two sample here. Here at least one variance is different at 5%. And look into this. P-value is 0. T-test is 3.35. F method. Now what we can assume? What is your conclusion? So null hypothesis is accepted here or not? All variances are equal. No.
Rejected.
Exactly. Null hypothesis is rejected means at least one variance is different. Means these two variances are different. We can't assume. So you can clearly see p-value is less than alpha value. Alpha is 5, p is 0. That means alternative. Alternative is say is at least one variance is difference. Okay, that's good. And you can
Can you repeat that, Professor, about it not?
yes, yes.
Because I was looking at the p-value equals 0. So if that's 0 and it's less than 0.05, would you not accept it?
Yeah, so here, this is the rule of thumb. I mean, please, throughout the statistics, you can keep it. Rule of thumb. Okay, just remember alpha is significance level. A alpha value, p-value, p-value is less than alpha value. That okay, let me start again. If p-value is greater than alpha value, this means null hypothesis holds good. Null hypothesis hold good.
Does that mean you mean accepted?
Null hypothesis is accepted.
Thank
or
you.
we fail to reject. If p-value is less than alpha value, we reject null hypothesis and we accept alternative hypothesis. So this is always reject null. So this is always true in entire statistics. So now let's go back on this part. Our alpha value is 5%. And what we are getting p-value is 0%. Okay, so if you remember from last, you were in 503? If not, then this is the rule of thumb. You can just, if p-value is greater than alpha value, then null hypothesis is accepted. Accepted. Okay. If p-value is less than alpha value, then reject the null hypothesis and accept the alternative hypothesis. Is it clear? Okay, so here null hypothesis, all variants are equal. That means, this null hypothesis is not accepted because p-value is less than alpha value. That means all variants are not equal.
Was the p-value, p-value is 0, so
Yes.
it's less than alpha, so you reject it.
Exactly.
Thank you.
Yeah, so, and this is eyeball test. It is called, you can see this is Seattle, you can see the spread of Seattle, how you can see the variance of Seattle, and this is here, this is, they are separate. So here we test the this situation. Now other option here we can use, we have again ANOVA and here test for equal variance. Let me clear this. Just okay. So here we have options. Use test if if sample is when do we use normal distribution? Let's say you have two sample, one is like 20 sample size, one is 10 sample size, then we cannot use this. Because you need to remember the normal distribution condition. So okay, let me do. Okay, and here we go. And here you can see, here we are going to use Levine test. And again, in that case, it is not equal. So now we are confirmed what we are going to use. So statistics, two sample. And now we have two sample in different columns. Seattle is right here, Spokane is right here. And options, assume equal variance. No, we are not going to assume equal variance because we checked ourselves. They are not equal. So, and now, okay. Now here, population mean of Seattle and population mean mu minus mu1 equal to 0. This is null hypothesis. So basically, this is all calculation is coming. We are going to work on this table or this last, part of the, and based on that, we are going to draw our conclusion. Now, you can draw your conclusion. Our null hypothesis is mu1 minus mu2 means population. First sample is Seattle, second is Spokane. Seattle minus Spokane is 0, and this is second is not 0. So null and alternative 0 or not 0. What you are going to conclude based on that? Which hypothesis is going to be rejected or which is going to be accepted?
Accept the alternative?
Yeah, yes. So we are going to reject null hypothesis. Null hypothesis says there's no difference between Spokane housing prices and Seattle housing prices. We are going to reject that because there is a difference. So alternative is going to be accepted. Null is going to be rejected because p value is less than alpha value. Is it making sense? So now we would like to check. So, okay, now there are three other options. So I'm going to show you. Now we have one more option. One is difference is less than hypothesized difference. This is alternative. Here, always remember this option is alternative. This is not a null hypothesis. Alternative says difference is less than hypothesized difference. That means, or difference is more than hypothesized difference. What do you understand from here? Let me show you. So here, just a minute. So if is Seattle minus Spokane, if we want to make it, this difference is greater than 0, then this is hypothesized one. Then what should be? This is the higher value. Seattle first sample should be higher, second sample should be lower, then only the difference will be higher. In second conditions, if Seattle minus Spokane If this needs to be less than 0, that means Spokane prices must be higher and Seattle prices must be lower, then only. So you can assume what we are going to see. So here we have difference is less than hypothesized difference. That means in that case, Spokane is, sorry. So this is the first case. Difference is greater than hypothesized, means Seattle is higher, Spokane is lower. Again, we are not assuming variance. And now, okay, we go here. Now what do you see? What do you conclude here? What is your conclusion? This is, I'm making a more bigger.
Would that be the alternative is correct? Because if you want a Seattle minus Spokane would be greater than 0.
Yes, so here p-value you can see again. P-value is 0 means null hypothesis is not correct, alternative is correct, which means first sample is higher than second sample. Let's say third, let's try the third option. And now I'm going to do reverse, and then you can see. And you can see here. P-value, that means null hypothesis is correct, alternative is not correct. Actually, all three hypotheses are written in this way. So here in Minitab, we only get equal to 0 or not equal to 0, but let me write here so that you can. So basically null hype, when we do greater or less, it is, this is, and then alternative is this. So basically it is written like this, or greater than or equal to. So this would be like greater than or equal to. So this is null hypothesis. Alternative is less than. So basically it is greater than condition is. So null hypothesis is correct in this case, that it is 0 or greater than. Is it making sense? Because null hypothesis, p-value is more than this. So p-value is 100%. This is 100%. Alpha value is 5%. And is it making sense? If you understand this concept, then you know it is just few things I would like to cover. So just a minute, let me remove this part. Okay, so if you remember that hypothesis testing, so hypothesis testing can be done based on mean. We were just looking about mean. Can be done on variance, or a standard deviation. Can be done on proportion. Mean, variance, standard deviation, and proportion. And so one more special case is about two sample hypothesis testing is paired sample. What is paired? Paired sample means a sample about the same in two different situations. Let's say MBA, before MBA and after MBA. Your salary before MBA. Now we want to see whether you have significant increase in your salary before MBA or after MBA. So this is about you. Then I take the sample of 40 students. Let's say 40 students are here. Their salary before and after. And then I will see there's a significant improvement in the salary after pursuing or after completing the MBA. Or I will, also conclude there's a no significant salary hike after completing MBA. So basically, this is, or after treatment, somebody is having some problems or health related. So before, after, before. So this is, so let's say a medicine, let's say you are doctor prescribed medicine. So medicine, let's say blood pressure medicine. So somebody is having blood pressure before medicine. Once after 2 hours of medicine, you have, like, you observe 50% of 50 different people before and after prescribing medicine or after medicine intake. And then you can say, yeah, there is a significant decrease in blood pressure prescribing this medicine before or after. So basically, you understand this is like a paired sample. If so, I'm just making it clear. So here let's say, this is a spoken housing prices, and before COVID, and this is after COVID. The same houses after this pandemic, the housing prices is this. For same house, it was valued about 350,000. Now it's about 500,000. The same house valued about 285. Now it's 425. So two different situations, but same house. So if you take this kind of sample, this is called paired sample. And here is the statistics as basic statistics and paired t-sample. So, I mean, let's say this is Seattle and Spokane. Those. So exactly the same option. Here you can see we don't have assume equal and unequal, rest is all same. So this is a special case when you see two situations of the same thing, then you use the paired sample. Here we come here proportion to proportion. And you remember what is, so you can take sample 1 from sample 2 and you can use the proportion. Again, this use the pooled. So basically these are the two options. Now we come to the statistics basic, two variance. You say the variance in Seattle is high than Spokane, or so each sample is on column. So Seattle and Spokane. Now use the normal distribution. Okay. And now here you can make. So here test for, and you can clearly see is standard deviation of Seattle, standard deviation of Spokane. So equal to sigma 1 is Seattle standard deviation, sigma 2 is that, and equal to 1. If both are same, then it should be 1, otherwise not 1. So null hypothesis is 1, otherwise. Now what we can say, this is sigma 1 upon sigma 2 equal to 1, not 1. And now p-value is not 1. We have already seen that, they are these are not equal. They are variance or standard deviation. Therefore, p-value is this, and you can see. Now, so these are the 4 cases. And when you follow these slides, you will understand everything systematically. Now, what about if you have more than two sample? Let's say you are going to compare Seattle, Spokane, and let's say Portland. What you will do? How will you see which is, are they equal? Or then we are going to check the ANOVA. So let's say I'm going to put here Portland. And I'm going to create the data again here, random data, and then integer. And I'm going to put Portland, and let's say I'm going to put like, okay. So I have now 3 samples, or more than 3 or 4 or 5. Let's say what I'm going to do, if suppose I'm going to do statistics ANOVA, analysis of means, and then again you can see using the same ANOVA one way. I'm just going to show you the plot. So let me, so we use the one way ANOVA to check, so this is basically a Seattle. This is a Spokane. This is Portland. Spokane and Portland prices are almost same. I mean, they are almost same, but Seattle is much higher. So basically, if you want to see more than 2 sample, you can use one way ANOVA and you can check that, which is the next chapter. We don't have in this module, but if you want to do. So this is, so basically you can have one more option under this. Here you go under assistant. If you go under assistant, here you see the hypothesis testing, and here you have all the options. You can select the which one you are going to. So 2 sample paired, 2 sample standard. So we are going to, let's say sample 1 is Seattle, sample 2 is Spokane. Is the mean of Seattle greater? You can select the statement based on that. Or I'm just 5 difference. And then you can see all the answer, everything right here. So basically you can go ahead. And this is also alternative option to choose the, but I prefer, this way. When you have clear understanding about the concept, you basically use this and you can decide which one is good. So this is about module 2. Whatever question you have, please let me know. I'm available to answer your question.
Can I ask regarding the assignment we're doing? Are we supposed to be testing all of I did the 2T and looking at all those. Are we also supposed to do the other ones you're showing, or basically do it off the?
So few questions are also based on the paired sample. Okay, so we are going to use, so under assistant, you can use hypothesis. We have all, regression analysis, hypothesis testing. So we are going to use hypothesis testing when you can see this. So one sample so this is, one sample that we did in the last class. We are going to do, and then you have more than, so one sample ANOVA, one way ANOVA. So yeah, in fill in the blanks or MCQ, you have also question related to paired sample. You have also related to proportion. Any other question?
Can I ask on the, separate from this, the exercises at the end of the chapter as you go through them? It says to use Excel or pull data. I'm trying to understand how to do those. Is it simply the formulas that are in the book? Can we put it into mini tab? I'm trying to understand how that works to
Okay.
prepare for the test.
At the end of the chapter, you have, let me see, at the end of the book. So just let me see if I
Or
can.
also throughout it, there's like 10.6, there's different ones throughout it.
Yeah, so just a minute, book. So my textbook. Or hmm, hmm. Can you please restate the answer to when doing the assignment? Do we do all 4 hypotheses? I mean, you need to select which. So problem is there, you need to select which problem can be solved through which test. So like, if you first understand the data, which problem is that? What question is demanding? Based on that, you can choose the right test. So yeah, you said about the data. So just a minute. So here, so we go here, right? For test. Okay, or let me download all the data sets from a different source. Yeah, this should be available. So we can't download here any data. Okay, so just give me, I will try to download all the data and I will put in the zip folder and you will have the access of all these data set to do the analysis. Yeah, we can't do because this is just textbook. So no, you can, so in the discussion, you can frame your hypothesis. Based on that, you can come to the process and you can decide the process. Let's say I decided I'm going to check the housing prices. Mean housing prices in Spokane and Seattle are different. For that, I'm just going to use only first method. If suppose I decided to check Huang, we are going to use 2 sample t-test only. No, you don't need to calculate. You can directly get through Minitab like we were getting here. So for example, this is, let's say, Seattle, and I can get directly answer here. For example, here 2 sample t-test and Seattle Spokane, and not assuming, and here this is, we are getting t-value calculated right here. This is a t-value right here calculated. We are going to check based on p-value.
Yeah, so that's for the case we don't know the variance, the population variance. In a case that we know the population variance, then we have to calculate the z-test, not t-test, right?
Oh, so variance, it's a chi-square test or f-test. So here, for example, f-test, in one we were doing that. So here just basic test, it's f2 variance, and here you can see and you get the f-test. So f-test is, this is the value test statistics. So for variance we use f-test.
Just for the difference in mean, different in means, but we know the population variance. That we use a Z test, not T test.
Mm.
You know, when we test the mean, the difference in means for the independent sample, we have 3 cases. The first case, we know population variance, and the case 2, case 3, that we don't know the population variance. The case 1, we know the population variance. We use a Z test instead of T test, right?
Yeah, so you know that was okay. So as I said in the beginning, let me explain. So if you remember the 503 course that we did, there we were comparing with the benchmark value, and there we used to have the population, known population standard deviation or known population thing. Here we are just working on 2 samples. We are not having the 2 sample population standard deviation. We don't have 2 sample population variance. It was only because we used to compare like H0, you know, mu equal to 525,000. So basically this we assume to have the housing prices in Seattle or Spokane. So here, if you remember the last now, so 1 sample Z test, because known standard deviation, because we used to compare with that. And now, so now we don't have this option here, because we are just going to work on 2 sample T test. We don't have, or paired T test. We don't have the Z option for 2 sample. Huang, is it making sense?
Yep.
Yeah, so that was in the previous, you know, 503, because we used to compare what, let's say, you know, what our assumption in null hypothesis over there. Let's say I used to make null hypothesis. Okay. The home prices in Seattle is like 500 or 625,000. So I used to assume, okay, this is the population mean, or you know, based on entire population, the average home price is 625K. But here we are not assuming, I'm just comparing the based on sample. I'm comparing Spokane or Seattle. Is it making sense? Okay, that's good. So I think for quizzes, yeah, so Carrie, the quizzes will, so let me see what we can do in quizzes. Where am I? Okay, right here. So most of the quiz related questions, so fill in the blank and preview, and here, you know, this is a summarized data, so you need to put the summarized information here. So many questions are related to here. So this is the data which you can get for this this, you know, right here you can download and you can directly put into Minitab. Similarly, other question will have the data right here that you can directly download and directly put into the Minitab. Carrie, is it making sense?
Yes, it is. Will there be any questions where we have to use the formulas like in the book to use the correct calculator to understand that? Or
No, actually, you know, everything directly comes in Minitab. So basically,
okay.
if you understand the concept, you don't need to do hard work to calculate everything one by one, piece by piece, or, you know, but if you don't understand anything, you are not getting any correct answer. What you can do, you can send me your steps in Minitab calculation, and I will let you know.
Okay, thank you. So
Yeah.
you will, just to clarify, you'll be getting the data we will need to do the exercises, correct? Because that's where I'm kind of stuck now because I can't. I
So
don't have the data.
So data related to the questions which are right here, right here, So if related to assignment, all the data is, within the question. So
Well, I
you
mean, in the exercises in the book.
exercise in the book, I'm just going to look into the connect part. If I can pull all the data, I will share. You will see, right at the bottom here. So just give me, I have another class. So, by 8 o'clock, I will, you just send me an email and I will reply to you. And I can put, if I get the data, I will put right here. You will check about 8 o'clock.
Thank you.
You're welcome. If you don't have any question, I would like to say have a wonderful evening and we will see each other next Tuesday. And this course is going to be easy because next week we will learn multiple regression and it will be easy. Bye-bye. Bye. Good night.
Thank you very much, sir.
Yeah.
Most welcome. Most welcome. Bye-bye.